Uh, so basically, if you look at a traditional telephone, you remember that I don't know whether yeah, you remember that there will be a rotatory telephone, then there will be a push type telephones. Okay, so it was there in early days. So basically, how this telephony works is like there is a centralized place called a switch. Okay, there will be it's basically a two copper wire. Okay. Basically, if you look at your telephony that days, from the pillar near to your house, you will get to two copper wire. Okay, so the same way there now all these uh, all your I mean all your network protocols also working. So you need, if you look at your RJ cables and all, it's basically a copper wire only. So they're transmitting the binaries, everything. Okay. And how this telephony works is it is converting from analog to digital. Whatever we are talking is analog and it has been converted into digital and it has been transmitted uh, to a nearest, uh, I mean, to the nearest telephone exchange. Based on the numbers, it will, I mean, it is going to the call is getting routed. Okay, suppose if you dial your Bangalore STD code 080, then call is been routed to Bangalore. And earlier, the first three-digit number of any telephone number is the area code. Okay, like if you look at 220 means it is it is Koramangala, and like in Chennai, if it is 220 means Korator, like that. That first three-digit denotes the area code. That's how they will do the routing. So how that routing happens is like whenever you lift your telephone, you will hear the dial tone. Then there is a current is being generated internally, and whenever you press the digits, that is called DTMF, or it is a pulse. Suppose if whenever you press a digit, if it hears it is hears like a rotatory thing or very slow things, means it is dialing in pulse. And if you whenever you press something and you are getting a beep sound like that, like if you want to dial 2200131 means, if it is a fast dialing, it is a DTMF, then you will get a tone like thing. So basically there is a frequency for each number to differentiate what tone it is been. So all these are being generated by ITU. Okay, that is International Telephone Union and Communication. There is a standard organization which have all these things been standardized. All these GTMF tones are being standardized. Okay, so that's why whenever you dial some number, it is routed to the uh, central exchange, and from that exchange it is based on the routing switching technology. It will switch the it will send the call to the corresponding switches, and it is getting then uh, patched. Okay, so basically how this will happen is like your network card, there will be a uh, card. Okay, in all the telephony stations, all the telephony exchange. So all these, that medium is called as E1 or T1 based on the regional, like countries like uh, US, they will call it as T1, and countries like Europe, they will call it as E1. Okay, E1 means at a time you can communicate 30 calls. 30 persons can communicate if you have a E1 card. If you have a T1 card means and simultaneously 24 persons can talk. That means 24 persons can uh, make a call. Okay, and now how these telephony signals are communicated between different switches. there are a lot of protocols is there, telephony protocols like international protocols like ISG and PRI, SS7, then CAS. There are a lot of protocol is there. It has been designed in a way that it has to capture all the things like your calling number, caller number, or any related information, like how you are passing your nowadays, how you are passing the HTTP header. Okay, like that. Imagine there is a set of key value pairs that has been passed through this copper wire using a standard set of protocols. Okay, assume like your HTTP protocol. These are all our binary protocols. As I said, this CAS, SS7, EON all are binary protocols. So, and it's also formed by the ITU standards. So, all earlier, that's how the telephones are communicated along internationally. You can make any calls based on all these protocols, because every switches in the protocol in the countries, all countries support either either of these protocols. Like I said, yeah,
Hello.
ISDN PRI.
Mm.
Yeah,
Hello.
yeah, yeah, Naren.
Uh, yeah, actually, I lost you. So for some seconds, actually.
Okay, okay, I will repeat. So what I'm saying is, the earlier stages, they everybody used to have this ISG and PRI. That is the very traditional protocol which has been used in all the places. I think even now, a lot of places they are using ISG and PRI. Then SS7, that is also in SS7 there are a lot of variances like ISAB. Then it is same thing like our network layer. Okay. So you remember that there is 7 layers of networking, the application layer, like that. This SS7 is also having lot of different protocols for different purposes they are using. So basically, this SS7 and all, it was used most of the times for all the in all the international levels for mobile networks and all. So earlier there is a telephony landline. You remember that is landline is the first. Then it comes mobile. So mobile they used for voice calls and all. They are using this type of telephony things. And then mobile, they have the latest technologies like 2G, 3G, now 4G, 5G has come. Okay. This and all different standards. And if you want to have for, and also for having different applications for using mobile, like for SMSC, for sending an SMS, they have a server called SMSC server. Okay. And basically they have a protocol called SMPP, short message peer-to-peer protocol. I think it's basically it works on the TCP/IP only. It is also a binary set of protocol to send the SMS between two mobile phones. Basically, it is going to if you look at your earlier phones, you can see there will be a SMSC center number. Whenever you send a SMS, that SMS is going to that particular server, which is nothing but it's like our uh, it's like our normal telephony server, but the only difference is this media is going through the air. From there, it is getting converted to that. You can see there are telephone towers, correct? So that is different concept, and in telecom, that mobile itself is a different vast concept. So like that, instead of going through a copper wire in mobile network, the media is air, and tele radio communications, it is going through that nearest cell phone tower, and that's how the message are being exchanged with the in case of mobile phones. Okay. Okay, so now this is the way the traditional things was happening, and I think in early 2000, uh, it comes the voice over IP network. Okay. See, basically, voice over network is nothing but you remember that networking of your systems. Okay, then how we can use that network to send the voice messages and to send the voice. Okay, so that's come the voice over IP network. So initially they have start with HESJA 323 protocol, that is the standard protocol which is being used for this voice over IP networks, basically for the internal, I mean, internal usage, like a PBX. Okay, for that only this voice over IP protocol has been used. Okay, I forgot to tell one more thing. You remember that like if you're if you are in a normal living environment in a home like environment, we used to have one telephone line. Okay, but in office, you cannot give individual phones to everyone. Okay, so to overcome this thing, there is a concept called private branch exchange, that is PBX. Okay, there is a concept of PBX has arrived. So the PBX is it's itself is having the capacity of equipping lot of telephones, connecting the telephone, lot of telephones. Okay, you can create a lot of telephone lines in that PBX itself. That's what every office is having a separate PBX. Okay, so that they can give an
Sorry,
individual
one
extension.
question. So PBX is some, is it same as a switch?
Yeah, it is similar to switch, but based on the I mean, they used to say like class 5 switches. Okay, class 5 switches means it is an international. It combines of all routing based on more complex switch. Okay, but PBX for internal purpose. I mean, it's mainly for enterprise. Okay, not for public use, mainly for enterprise, with most of the facilities or functionalities available in the standard telephone lines. It supports. Okay, for business things they have this all these things, PBX. Okay,
Okay.
it's I mean, if there are 1,000 functionalities there in the telephone, normal telephone things means, in PBX it will be around some 300, 400, something like that. Okay. So based on the size, capacity, and everything, this PBX varies. Okay. For suppose if it is very small concern, then there will be a small box. It supports up to 16 extensions. Okay. So like that, based on the this thing, the PBX have all the extensions. Okay. Other than that extension, it is having a input cards like as I said earlier, the ISDN PRI and all. So now what will happen is, suppose based on my call volume, I can choose my number of input lines. Okay, suppose if I'm getting in a peak hour, I'm getting some 20 calls means, then I need 20 lines of telephone. Okay, so uh, but if you want to maintain the 20 lines of telephone, then if something goes wrong, you won't get I mean, you won't able to land into that particular number. You need to provide 20 lines to 20 line numbers, individual numbers to the each of your customer. So in order to overcome this and all, as I said, there's E1 T1, that concept has come, so that it consists of 30 numbers. You can have a single number that can be diverted to the each channel. I mean, 30 numbers means it will be of 30 channels. Okay. So like your hammer, you have channels, correct? Like that, there will be channels in each of the card, and you can assign an individual number to that, so that like a hunt group. Okay, it can land in any of the free channels, or it can land in any of the least occupied channel. Like that, they have the different algorithm, and that and also called digital signal processing, that is done by the digital signaling processing algorithms. Okay, so that calls getting routed to the I mean, suppose if Servian is going to buy only one event card, then they will get 30 lines, 30 simultaneous telephone calls. Okay. Now normally what they will do is they will transfer that to a auto attendant. You know what is auto attendant? That is dial one for sales, dial two for marketing, like that. Based on that, for each one they will assign a internal extension. So the PBX now, based on the whatever you are dialing, it is getting diverted that call to the individual extension. That and all configured in the PBX. Okay, like that. If you have voicemail, once that call is being not answered or busy, you should go to your voicemail. Voicemail is nothing but another telephony server. There you have that some IVR like thing which will answer your call on behalf of your unavailability, and that is getting answered, and your voice is being stored over there, recorded over there. After some time, I can able to access the voicemail and see who has contacted me. Okay, now you are having a missed call, like earlier they have this voicemail concept, but nobody leaves the message. Okay, at least I should know from where I got the call and all. So this is what basically a PBX is for. To the input to the PBX is based on the necessity, a U1 or T1 line, and it is getting converted to each of your transferred based on the your I mean based on your requirement. It is going to transfer to each of the individual thing. And also, if you want to dial directly, I mean. As I said, they have this since they allot a number like a 4233 128. Okay, so and they will have some hot link number, something like that, so that they will provide a individual telephone number to each one. So there is a concept for that. I don't remember that one. So that like that, lot of functionality is there. Like I said, there is a call routing functionality. Then there is a voicemail functionality. Okay. Then there is a I mean auto attendant functionality. So like that, the PBX itself is having a lot of things, and sometimes this PBX works internally with earlier it was with some digital cards. Okay, suppose you want to know from which number I got the call. Okay, so if you want to tap that PBX and all, I mean, if you want to know what is happening in the PBX, then they have a parallel line from the telephony, like your so what you will do, suppose if you want to access if you want to get a power from your for your house. Okay, one thing is you can get a direct connection from EB, or you can take a without knowing the EB, you can take a connection from near your post. Okay, that's how the government meetings will happen. So like that, you can do a parallel tapping from your telephone line, and you can read all the bytes in the telephone line through some digital signal DSP card. Okay, digital signal processing card, and you receive all the information, and you can see what are the things going on in the telephony lines. That's how you can tap the telephony lines. Okay, this is one thing regarding the how you can retrieve the information from the PBX. So earlier days it was all our digital signal processing card. Even though now everybody is all the gateways, all the gateway voice gateways, everything is using all this. Uh, I mean DSP processing card. It's something similar to your assume like a network card. Okay, okay, so something like that. Based on that, it is going to get the information from the all the details, incoming details of the calls received in your PBX. So this is how the PBX functionality and it has been working. Okay. Okay. Now, how do you? I mean, how do you access this? telephony information in a computer. Okay, now there is a PBX. How do I get that information from in a computer? Like as I said, parallel tapping is one of the thing. Another thing is like all these telephony servers are is basically a I mean it is basically a it's a telephony servers, all it's like a servers, so anybody can I mean that the provider itself provide you the some of the SDKs, okay, to connect to the telephony servers and get information related to a call. Okay, so for that only like different telephony vendors like Avaya, Cisco, okay, they have a PBX and they provided some of the SDKs and they provided some of the um I mean APIs, not APIs, some of the libraries used by the telephony. You can write your own application to communicate with that PBX, and you can get the information from the all the telephony related stuffs. Okay, so that's how the industry changed. I said earlier it was a tapping, then it has been given by the um, telephony provider itself. Since everything is standard, they provide a library which can be used in common for all the thing. There is a library called TAPI, TAPY. So that is supported by Windows and also all the third-party vendors. So that with the TAPI you can write any of the telephony application. Yeah, okay, so the whatever maybe based on the version, I think now yeah, I remember it was Tappy 3, I think, and the Tappy 2 also is was there. So when you write an application in that, you can have your own IVR, you can have your own, you can play the voice. Okay, suppose if you want to write our own IVR application, you can use the Tappy also. Okay, and the Tappy is being extended by most of these service providers like Avaya and Cisco. I think Cisco
So
is using
Pradeep, one
Tappy.
question. So TSAPI,
TSAPI is a proprietary protocol of Avaya
Avaya,
for their
okay,
Tappy is a standard.
okay.
Okay, using Tappy, you can. I think a lot of switches they are using like Mitel. A lot of them are using. Cisco is using Tappy for telephony. What happens in your telephone lines and all? You can use Tappy. Okay,
Mhm.
that is telephony application protocol interface. That is a very vast thing. So like that, yeah, if you want to monitor the telephone lines, they do have all these APIs and libraries. And based on each individual vendor, it may get different. Like Avaya, I said, is a TSAP. It is a uh, I mean, it is a C++ library, and for C Sharp, they are using DMCC libraries. With that libraries, you can record the phone call in Avaya infrastructure. You can do I mean, you can do screen pop-up. So a lot of things you can do with this thing. And the one thing is very advantage of using this type of third-party applications is you whatever I mean in they have abstraction is I mean they have a single abstraction. You can I mean you don't know what is happening behind the scene. Okay, the phone may be using a SIP the phone may be a SIP phone. Okay, the phone may be a HZR33 phone. The phone may be of any other protocol. If it is a Cisco case, there is a skinny protocol which is yeah, I mean which is the proprietary protocol of Cisco, predominantly used by them in early days. Now that it's been converted into SIP and all. Okay, so basically how these things are working is like basically request and response and events. All these telephone applications are request and events. What do you mean by request is whenever a call comes, I used to answer the call, okay? Or I used to place a call. Place a call means make a call. These are all are called request. In our hammer case, you can see there is a place call. Place call is a request, okay? And release call is a request. Sometimes they would call it a drop call, okay? So request and events. Events here is are some telephony events pertaining to the protocol. Whenever suppose how do you know that there is a call has come to you? Okay, so you need to wait for a call. How do you know that a call has come to you? That is called a event. Okay, so basically, whenever you got a call, there is a ringing event. Okay, so, but in case of a normal standard telephony, they will call as an accept offer. Okay. In a standard way, they will have different thing. Call accept, call offer accept, answer like that. There are different types of events will be there. Okay. So we need to do all the operations. Whenever the call is been accepted, you have to answer that call. Okay. Whenever call is been answered, then you can able to put the call on hold. Okay, so like that, a lot of telephony operations are there. Is there hold, retrieve, then transfer, single step transfer, conference. Okay, like that, different operations are there in the telephony layers. So basically, what I said is a telephone line. Then comes the PBX, mobile phones. How do you retrieve information from the PBX? Tapping the line. Then there is protocols, a TAPI, a standard way of communicating with this PBX. Then there is a proprietary related to each of the service provider, the PBX vendor. Then comes a uniform interface, which will be used to uh, communicate with the PBX, irrespective of the protocols used by the PBX. What I mean that is, a phone may be any type of phone, but you are using a same API, events will be same. Okay, maybe the while the events it denote what type of phone the call has come. Okay, like caller ID, calling ID, who is called the phone. Okay, on which number, what number it dialed to reach you. All these type of informations are coming in the events. As I said, the offer, accept, answer, like that you can get the call related details in that event. Okay. So this is how, in general, the telephony will be there. How you want to access the telephony, PBX and all. Uh, you need to have a driver or SDK using the library. Using that library, you can communicate. But behind the scene, the infrastructure may be a traditional TDM based that is called, I told you earlier, correct? E1 T1, or it will be a voice over IP protocol that there is no need for you need to know what it is, but in general, they will call this a CSTA protocol. This one, okay, CSTA protocol. What that it will do is it will have an abstraction for a telephony functions and events, okay, and it have that capability of recognizing the infrastructure, whatever the PBX uses, okay. So this and all defined by the ITU standard. That is, uh, ITU standard. They have all the definition for the what is CST and all. Okay. So this is the in general telephony. Okay. Any questions, Dennis?
No, like getting the flow.
Okay.
Pradeep, so where that ACD comes, Pradeep, in that telephony system?
Okay. So you remember the what is the use of telephony now? Okay, it is
Mm.
to between two persons they used to talk and all. Okay. So now where it comes to telephony, ACD. Okay. Now every PBX vendor uh, have a, I mean, they promoted the telephony. They want to have it in a sell their thing in a different concept. Okay. So in that case, only this contact center has come. So basically, each one is each agent is having a telephone lines. Okay, and the call has to be routed to the corresponding agents. Okay, so how do you integrate? This telephone is a dumb box. Okay, it knows how it is a signaling only. It knows how to communicate between two devices. Okay, but it doesn't have a influence or logic to I mean route some routing to a particular skills. Okay, so so you can say this, that's what the ACD has come. Okay, so ACD basically what it contains is it give a logical name to each of the persons, and it is a separate software entity, correct? There will be always like as I said, a voicemail server. ACD is a server which is a part of all this which is a part of uh, which is a part of all these contact center applications, PBX. So internally for talking between the ACD and the telephony switch, okay, they do have some other protocol. I said earlier I said TAPI, correct? TAPI may be a server that it can integrate with ACD to give the real-time telephony status of an agent internally for a PBX. Okay, so this ACD maintains the each telephony state as well as the agent state. Okay. A couple of things. One is telephone state and is agent state. Agent state is nothing but agent login, log out, and not ready, ready. Those are agent state. And the telephone state means call answered, call dropped, call hold, retrieve, transfer conference is the telephony state. Okay. So basically, ACD don't have this telephone state, but it have the agent state. But how does it will know which agent is in call and all? That details that ACD is having, that it is getting from the switch or any of the telephony server. Okay, so it is something like you are writing a server which will do a intelligent routing. Okay, so am I answer your question, Aaron?
Yes, Praveen.
So ACD is nothing but a telephony application only. Okay, which talks in between your telephony server and your agent client.
Okay.
Okay, okay. So like your HVA, the status is coming from the ACD means it is talking internally to the HVA library, whatever Genesis library, internally connects to one of its server and it is getting the information. Okay, as I said, the abstraction, okay, remember that you don't know whether the telephone belongs to a SIP phone or it is any type of phone, you don't know, okay, but your application works, correct? So that is the mostly it is a internally they use the CSTA protocol only, okay, for all the I mean for all these service providers. So this is how in a contact center environment the telephony works. I mean you can have a voicemail system, as I said, auto attendance system. This is all a basic thing. Even everybody is using it. Okay, and then the contact center application like that, different guys, and also the infrastructure requirement for this and all. It's It's all real-time gateways. We can have, they will say incoming gateway means ingress gateway. See, as I said, E1 T1, correct? Uh, Suppose if a contact center is having 1,000 agent, okay, then they don't have 1,000 lines, okay, but they do have some lines, and they will have the call put in the queue, okay. So they have to check. I mean, for 1,000 lines, how much they have to pay. So this and all, to avoid this type of things, this contact center helps them to minimize the. That's what they want to have all this. How fast the agent is answering the call, how much time the agent is holding the call. Based on this and all, they have a monitor, and they will have a supervisor who will give the training to them to attend the call quickly to solve the problem to minimize the cost of the telephone networks. So that's what you can see some of the notice in our, if you look, there is in, if you see in all the pillars in Servian, they have written the customer talk time has reduced to this many hours, something like that, due to Servian's contact center infrastructure thing like that. So basically, your network should be super fast. Okay, your application should be super fast to answer all the calls. So like that, there are different things you require to. Uh, One thing is customer satisfaction, and another one is for me, for as a company, it should be a very less cost, okay, cost effective solution. So for this and all, only we have this dashboard. You remember that supervisor coaching. Okay, so like you remember nowadays for this, what is that? Your agent assist in Google Dialogflow. Whenever you speak, it is going to take the from backend and it will showing the agent. This and all to decrease the call time. Okay. Suppose if I want to, if my hovering billing hour is very high, then I need to pay high, correct? For 1,000 set call center, if I'm going to daily, I'm going to talk with many customers, and it is taking very long time, means I need to pay more. So if I have a proper planning and proper thing, then I need to pay less. For that only they have all these applications, recording application, and see how the agent is performing. Okay, WFO, WFM. Then speech
Mm.
analytics. Based on the speech, they will derive the outcome of the agent's requirement, and that is getting followed by some other team. So like that, lot of applications you are having in the in general in a contact center perspective.
Okay.
S- okay, so this is a very high level how a telephony and what are the applications a telephony can use. As a contact center perspective, what you can do. Okay, as a contact center perspective, what you can do is you can test your contact center whether the phone is working or not. That's how we are doing in the Hammer. Okay, you have an extension, whether the extension is working or not in a contact center. For that, you run the A side script and B side script. Okay, in any of the Cisco, I told you there is a extension has to be configured, that is been configured in your PBX, and that each, I mean, in each channel you can give the extension, you can assign that extension number, and you can, I mean, virtual, you can have a virtual thing, and you can run the telephony on your own, and you can test that each individual lines. Like that, HVA is used for agent information, for testing the agent. Agent can log in, log out, we can make not ready, ready, not ready. Okay,
Uh,
then he can take.
pr- Pradeep,
mm,
one question. So,
mm,
now we are using Genesis server in HVA to test. So,
mm.
do we require something like the Cisco IP communicator or the Avaya 1X communicator? So, is there anything similar for Genesis thing to handle media things?
Uh,
Uh, uh,
no, no. You can you do one thing. If you have the if you know that Genesis extension, okay, then there will be a state machine for Genesis. Like your SIP phone, I think there should be some. We need to check whether any whether SIP itself will working for Genesis or we don't know. I mean that Hammer configurator.
okay, okay,
So you need to select the correct project. Okay, and you can assign the extension. That is the phone, like your Avaya communicator phone, Cisco communicator phone. That is the phone. You can use it for Genesis or even Avaya or whatever it may be. You remember? I don't know whether you are that time or not. See, it will simulate all the telephone lines, all the extension.
okay.
Okay,
Actually,
but
I never tried this hammer with telephone systems. So registering Avaya, Cisco, and those things. So
mm,
right now we have only tested with the SIP only. So that's
mm.
why
No, that's what
I'm not sure.
they had named the. You can see that all the project names you can see, or you can that I don't know. Lad will test that Genesis, I think. Okay, but
Okay,
so normally they will do a Wireshark and see, and they see the packet and they are changing that.
okay.
Okay, so yeah, we know that whether we can test with for if it is Avaya environment, we will use Avaya IP communicator soft phone. If it is Cisco means we use Cisco, but in Hammer case that is not required. With the Hammer configurator, choosing the correct protocol. Okay,
Yeah,
the
but for this is only for testing purpose, right? For in terms of enterprise, they will have something, right? Similar to Onex
yeah,
communicator or something like IP communicator.
yeah,
In
it,
yeah for hammer I think we don't require because we are using for testing only. So
mm. Yeah, they will have hard phone or soft phone.
some software, yeah, okay, some hard phone or soft phone will be there. Okay,
Yeah, basically they without having phone, there is. I mean, with the PBX having there is no phone means it won't work out correct. So there will be normally a phone. It may be a soft phone or hard phone.
okay.
Okay. So, Dennis, any question?
Oh, so far, like, so we discussed still agents as from PBX.
Yeah.
Yeah.
So now we talked about a very high level thing. Okay. Like as I said, there will be a single library which is a CSTA protocol or any proprietary protocol that will interact with the PBX and it will get you the uh, events for a call, okay, or events for a normal telephony lines. Okay, as I said, this abstraction, uh, I mean, it won't let you know what it is happening behind the scene. Whether your phone is a SIP phone or normal SR33 phone or TDM phone, you don't know anything about that. In the event, you can able to see that one. But your operations are will be same with the all these APIs, all these libraries. Okay, you simply can say answer the call. That's all. The phone may be of any type of its protocol support. It will answer the call. Okay. So this type of APIs or libraries, they generally have a protocol called CSTA. Okay, that is supported by many of the these telephony providers. Okay, now if you go on step back, then it comes what type of protocols it is used by the all this telephony infrastructure is mostly they will use uh, SIP protocol nowadays. Okay, which is a session initiation protocol, which has been which is been used to communicate between two endpoint. Okay, here they will call as a endpoint. In the endpoint may be anything. Okay, normally they will call user agent. Okay, user agent. They will call as user agent. So there are different SIP network elements are there. Okay, like as I said, user agent. What is a user agent? User agent may be couple of things. A user agent is maybe a user agent server or user agent client. Okay. Then there is a proxy server. So proxy server, there are also outbound proxy and normal proxy will be available. So what is the need of proxy server is it hide the information from your internal infrastructure, like other proxy server, how it is like your HTTP proxy, how does it work? Similar way, SIP proxy server will also work. Okay, then there is a redirect server. Whenever you call is been coming to that SIP server, it redirect to some other server. Then there is a location server. I mean, whenever a user agent, okay, um, whenever user agent comes up, it will register to the particular server and it will give its location, like which IP address it has been there. Whenever there is a external call comes, then for finding out the corresponding address of a particular user agent, this location server will be useful. Like then there is a back-to-back user agent. There is a concept. There is another back-to-back user agent is there. Okay, so there are a lot of this type of, I think 6 to 7 SIP elements are there. Elements means a SIP device can act as a different with the different features or functionality. Okay, logically, it's a logical thing. Okay, so let us first talk about what is a user agent. Okay, user agent is any endpoint. Okay, endpoint is maybe a telephony endpoint. Okay, or it may be any device which supports, which is capable of having a SIP as a one of the thing in your I mean in your real time thing. So apart from your you can have your hot phone is one of the SIP endpoint. Your smartphone is one of the SIP endpoint, or your car may be one of. Suppose if you're having your car is having any telecommunication devices, is one of the SIP endpoint. Okay, so like that, there are a lot of SIP endpoint is there. Normally, this is called a user agent, and this user agent is of two types. Okay, one is user agent client, and the other one is user agent server. Okay, so what is this user agent server and client means? Suppose you remember as I said, all this SIP is a voice over IP protocol. What do you mean by voice over IP? It's basically an internet protocol, okay, IP protocol, which has been communicated between two end devices using either TCP or UDP protocol. Okay, so basically underlying is TCP and UDP. Okay, so suppose assume that you Narendran and Dennis, you are having a SIP endpoint. Okay, you are having a smartphone which supports SIP. Okay, so that is called a user agent. Now a user agent can act as a user agent client when it receives the call. Okay, sorry, when it makes a call. So assume that a server is in, a software, a user agent is always having a user agent server and a client. A server means it is going to accept a connection, correct? A client means it is going to connect to a server. Like that, if you look at your phone is capable of accepting a connection. That time the phone is called a user agent server. That means suppose Narendran phone is accepting a call from Dennis means The Narendran phone is called as a user agent server. Yes, server is the one which is going to accept the call, correct? And Dennis phone is the one which is the user agent client. He is making the call. He is connecting to the Narendran's phone. So remember what is user agent server and a client?
Oh, yes, Pradeep.
Are you able?
Yeah, and
So
I can
basically,
understand.
yeah, basically a SIP phone is having the capability of both user agent server and a user agent client. Okay. So based on the based on the call type, call nature, it is going to change. So 5060 is the protocol. It's a UDP based port which is used for all the SIP application, like your 80 is for normal HTTP port, correct? Like that 5060 is the SIP protocol, which is used for SIP protocols. It's a UDP based. Okay. Mm. Okay. Now we will talk only about user agent only. Okay. Yes, proxy and all also. But if you want to talk, you can talk a lot. Okay. So now whenever a user agent, okay, basically now let me divide this SIP protocol, how it looks like. Okay. Assume it's like a HTTP protocol. Okay, it's a request response. Whenever a user agent client is going to call a user agent server, it is first going to send a invite message. Okay, I think I need to share that screen.
Pradeep, whatever you are sharing, share the link in the chat window as well.
Okay, it is tutorials only. Okay. Okay, I will share it. So without proxy, assume that without a proxy,
Hello, Pradeep, can you hear me?
so it will send a first invite.
Hello,
Yeah.
some network issue, Pradeep.
Okay. Now it's
Sometimes I
okay, huh?
don't. Yeah, now it's okay. Yeah, you
Okay, now it's okay.
continue. Yeah, yeah, yeah. Now I can hear.
Okay. Okay. So this invite message which contains a request. Okay. Then some headers. Then some it is having some details like session description. Okay. So these are a part of the invite message. So basically, we will see what it is inside sometimes later. Okay. Uh, so basically, it contains uh, the session description that is called SDP, like what type of codec it is supporting. Okay, in which port it has to listen for the media. Media is nothing but this RTP, RTCP. Whatever we are facing is getting converted into analog to digital, digital to analog. I mean, this digital, this called real-time protocol, RTP. Okay. So this is for call establishment is the SIP protocol. Okay. And for describing the session is called SGP protocol. Okay. And for sending voice between to these two things, it is called RTP and RTCP. But this is a itself is a huge chapter. You have to follow the RFC 3216, I think, which contains all these things. 1 second. Hello. Hello? Hello? கேக்குதா?
Yes, yeah, we
Okay.
can hear.
Okay. So basically this invite, this is for establishing a session, okay, call session, okay. And that
Pradeep, one
session,
question. So what that proxy does here? It's
no,
kind of
proxy.
mediator.
A proxy normally what it will do, it will all everybody will send a request to a proxy. Proxy will then request to each. I mean, it will send the thing to outgoing, outbound proxy.
Okay,
Just it will pass the information. That's all.
okay. So
See, instead of each one is handling the thing, if you have proxy means proxy will handle all the signaling portion, and finally media will goes between these two endpoint.
okay.
Okay, for security purpose, uh, everybody will contact proxy only.
Okay. So, but media packets will be between these two endpoints, direct and
Yeah,
endpoints, right?
yeah,
Zip endpoints.
yeah,
Yeah, okay.
yes.
Okay, thank you.
Okay, so that's what this 100 and all starting with one are called provisional messages, like 100 trying 200 is 200 okay is one of the important message. Okay, and then yes, async, say ACK acknowledgement. Okay, so invite, he sent 200 okay, then 200 okay is gives give acknowledgement, and then come then RTP is flowing between these two things. Then any of the guys in the call means buy will come. Then for that there will be 200 okay. So then there is a concept called I think a transaction. I mean each one is called a transaction, and oh, one more thing is that I forget. Okay, maybe next tomorrow we will go in depth in SIP protocol. Okay.
Okay, Pradeep.
So yeah, that's how telephony, how it has been contact center, how it has been internally, how the VoIP protocol works, that we will see.
Okay.
Then how it is getting how in Hammer it has been done also we will talk.
Yeah, Wireshark debugging also required, Pradeep. So that would be helpful. Yeah.
Okay. Okay, that tomorrow we will see that.
Yeah. Okay. Thank you.
Okay.
Thank you
Okay.
so much. Yeah.
Bye.
Bye.
இன்னைக்கு கூப்பிட்டாருங்க, நான் பேசிட்டேன். இந்த 100 அடி போருக்கு கொட்டேஷன் கேட்டிருக்கேன் வந்துட்டு. ஓகேவா? எல்லாம் மெட்டீரியல் முதற்கொண்டு அவங்கள என்னென்ன தேவைன்னு சொல்லி அதை திருப்பி ரீஇன்ஸ்டால் பண்றதுக்கு என்ன தேவைங்கிறதுக்கு கொட்டேஷன் கேட்டிருக்கேன் அவருக்கு வந்துட்டு.